Good morning, my name is Dodin. I'm a 12th grader at the modern Monticello school, and my project is called A New Innovative Way of Using Water for Irrigation Through Water Crystallization. To start off, 70% of our precious earth is filled with water, and I find it very ironic that one of the major problems we face nowadays is water scarcity. As a student in the Hashemite Kingdom of Jordan, it's my obligation to realize that Jordan is one of the poorest countries with water, and it's also my duty to find new ways to save or preserve water, and even if possible to establish new water sources. Therefore, after studying a characteristic called water crystallization, I began thinking, what is water crystallization? Well, water crystallization is the ability for a chemical to absorb water vapor and store it on its surface. Therefore, I told myself, this unnoticed and unused water, why don't you actually use it for the benefit of countries such as Jordan? Therefore, I started by asking myself 4 major questions. Firstly, fresh water is not abundant, therefore can we make use of the humidity, which is a source of fresh water? Secondly, what are the chemicals that have a high absorbance rate? Thirdly, if I found chemicals and I was lucky, what's the right container or system that I can place them in which will enhance their performance? Fourthly, if a chemical is found and a container is found and I was lucky enough to actually achieve water and establish a new water source, what would be the best use for this water source? Agriculture, home use, industrial. Therefore, without further ado, let me jump into the prime core of the whole project, which is the system. This is the system as you can see here. The system has a general idea. You see, it has made 2 components. First of all, the semi-cylindrical stainless steel shape, and the clay wave box, which is stuffed with the chemicals. Basically, the sun rays penetrate the declining glass onto the system. The system has a semi-cylindrical stainless steel shape, which is calculated to reflect the sun rays exactly onto the axis of this box. It will heat this box enough to make the water crystallization in these chemicals to evaporate. This evaporated water will condense with the glass, going all the way down to the water exit and out of the system. Well, as I said, the system has 2 major parts. The semi-cylindrical stainless steel shape with the suction fan down and a thermometer to ensure that the heat is reached everywhere and to ensure that only humidity is increased inside where the excess air is removed. Also to ensure that the water is separated from the chemicals. And the second component, which is the clay wave box, which is made in such a way to ensure that all the air particles and the humid air particles reach every part of the chemical and it increases humidity. Well, the major question is, okay, you understand the general idea of the system. However, what are these chemicals? What is this container? Why did you choose these chemicals exactly? Well, a series of scientific experimentations had to take place. First of all, I used many vast materials, many vast chemicals that are found in the lab every day and not found in the lab. Of course, I chose them according to the chemistry books, which say which chemicals have a higher water crystallization than the others. Therefore, I started off by putting a regular procedure, which is basically measuring roughly 8 to 9 grams of the chemical, placed above the water bath for 24 hours, let's say for 120 Celsius, because we just need the steam. And then after that's done, measure the mass of the humid chemical, place it in an incubator for 90 minutes, let's say on 30 Celsius, and then remove it again to measure its mass again. Basically, what you do here in the calculations is it's the difference between the mass of the humid chemical and the mass of the non-humid chemical, which gives us the absorbance rate. Well, I admit, of course, that you can never go to success unless you go through failure. Therefore, my first failure was my first experiment, which was predicted. Since the water bath had 120 Celsius, which is too high, which caused the plastic petri dishes to actually disform and the chemicals to actually melt. This caused for the fixing of this variable from 120 Celsius to 30 Celsius. The water bath was linked to 30 Celsius because the average temperature in Jordan is 30 Celsius. Therefore, I repeated the experiment once again, and I reached new results. The results were remarkable: 14%, 30%. However, it's certain that the average water crystallization rate in any chemical is about 5%. Therefore, I found it very ironic that a regular student can find such results, and I was sure something was wrong. Therefore, after further analyzing and examining the whole procedures, I realized a major error. The water bath was covered with a metallic plate, causing the steam to actually condense on the metallic plate and fall back on the chemicals itself, causing the whole experiment to be a massive error. Therefore, the whole chemicals were repeated the same procedure: 30 Celsius for the water bath for 24 hours, 90 minutes in the incubator for 30 Celsius as well, and finally without the metallic cover. And that's when I found my first concrete results which were found. I found one chemical that was striking, which I actually estimated that it will have a high crystallization rate, which is sodium carbonate. Sodium carbonate has a 7.91% absorbency, or a 6.71% absorbency, sorry, which actually was gave me motivation to search for other mixtures. Also, after I found these results, other than searching for other mixtures, I designed the first sketch system. It wasn't certainly like this, but I just sketched a system. Therefore, after finishing this experiment, I came up with new mixtures of sodium carbonate and many more, and did the same procedure to them exactly. I found a striking chemical, mixture 4, which was actually the chemical that I used, which was basically a mixture of sodium carbonate, sodium carbonate, sodium hydrogen phosphate, copper sulfate, sodium sulfate, and magnesium sulfate. This chemical, or this mixture, had a 7.91% absorbance rate, which was relatively 8%, 3% higher than the average rate. For me, this was enough to actually search for a container that would enhance its performance. Therefore, experiment 5 was basically enhancing the performance of mixture 5 to the container. However, I started by asking myself, I will not waste many time searching for a container. Therefore, I would research it thoroughly to find it efficient, not only by its absorbency rate, but by its cost as well. Therefore, I found DAS clay. DAS clay is a kind of clay found in all libraries in Jordan for a very cheap price. Also, it has a high absorbance rate. And therefore, I decided to proceed with using this clay. If it had a higher percent than 1% absorbency rate, then I will use it for the whole system. The procedure went as follows. Create a small petri dish-like shape from the clay. Measure its mass. Place it above the water bath for 30 Celsius for 24 hours. Measure its humid mass. And then place it in an incubator for 90 minutes at 30 Celsius. And then remove it again and measure its mass again. Same calculations as for the chemicals. I found that my first solid concrete results and best successful results were that DAS clay had a 2.765% absorbency rate, which, all in all, when placing this DAS clay with the chemicals, as you can see here, pushed the 7.91% absorbency rate all the way up to 10.5% absorbance, which is 201% more than the average. For me, these were remarkable results, which was an actual push of the average. Therefore, I decided to proceed with the system. So basically, that's the whole idea behind the chemicals and the DAS clay. As you can see here, they're humid and they will release water. However, the system revolves around two major questions. Is the system efficient? Also, what makes the system so efficient and so good and so reaches so achievements? First of all, I would like to say this system is officially a new water source, a renewable water source. As long as you provide it with natural air found everywhere on this earth, this system will keep on giving you water. I tested the system on very difficult conditions, 14 Celsius, 20 Celsius. The maximum amount of temperature I reached was 25% Celsius. Of course, I did not expect major results, however, the system came through. This system gave its first results, which was 0.5 liters on 14 Celsius, which is remarkable. And then finally, the major results came in when I tested the system at 25 Celsius, and the system gave 2.5 liters of water per day and a half. Therefore, after I calculated specific results, it has seemed that a regular farmer in Jordan will just have to pay the cost of this system. This system will keep on giving him water for 2 months to cover its cost, and then imagine, only 2 months of paying for water and having 2.5 liters of water free for the rest of your life. This is what makes the system actually efficient, since it's free water for the rest of your life from the air. Finally, what can I do to actually improve the system? I am definitely looking forward to actually working and finding new chemicals which have a higher absorbance rate, because I know I can find them. Also, this chemical has a very certain characteristic, which is increasing its surface area increases the amount of water extracted. Decreasing it decreases the amount of water. So imagine decreasing the surface area of this chemical in this system to the palm of a hand and placing it above a tree. The tree will water itself. Imagine making the system much bigger in surface area and then taking it to factories and giving them and supplying them with water. Also, it is found that the water extracted from these chemicals and from the actual air is efficient for the plants and for plant productivity. Therefore, this water is perfect for the productivity of plants as well. And to conclude, this system is unlimited with the amounts of things it can do. What is more, it will keep on giving you water for the rest of your life free. As long as we have air in this earth, you have free water. Thank you.